Assalamu alaikum. I'm Reem Yassin again, and I'm going to explain the third part of the history of development of astronomy. In this part, we're going to explain the heliocentric theory of Copernicus, Kepler, Galileo, and Newton, and then recognize the development of astronomy during the 18th and 19th centuries. Just remember, heliocentric theory considers Sun as the center of the universe, and we're going to talk about Copernicus first. The first to suggest the heliocentric theory in the 16th century was a Polish man named Copernicus. He demonstrated with a great precision that all the problems with geocentric model of Ptolemy instantly vanished if the sun is the center of the universe. According to Copernicus, the retrograde motion is now simply the result of Earth overtaking Mars at a particular time in their respective orbit. As we pass by Mars, faster, there is a moment where it appears backwards, just like when you pass by a car on a highway. Then his model is represented as the Sun, the center of the spherical universe. Earth is a planet like any other planet. The planets are carried by solid and transparent spheres, and each planet is driven by the uniform rotational motion of its sphere around the Sun. The fixed stars are carried by the sphere that has the longest radius. The period of revolution of a planet around the Sun depends on the distance that separates it from the Sun. The Earth revolves around the Sun in 1 year and at the same time rotates on itself in 24 hours. The Moon is a satellite of Earth and has a uniform circular motion around it. The planets are located around the Sun in the following order, from the closest to the farthest: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Copernicus' ideas marked the beginning of modern astronomy. The observations became more frequent and more accurate to verify these ideas. Never accepted Copernicus' theory. Tycho Brahe made remarkable observations. During 25 years, he accumulated precious data on the motions of the planets. He invented several measuring instruments with which he performed invaluable observations with the naked eye. Brahe died in 1601, leaving all his paperwork to his young assistant Johannes Kepler. Kepler convinced by Copernicus' theory, but he realized that the orbits of the planets were not circular but elliptical. He published 3 empirical laws, which are: the first law, the planets move along ellipses around the Sun that is at one of the foci. The second law links the planet velocity to its distance from the Sun. The velocity decreases as the distance increases and vice versa. This verifies why the time span between March 21 and September 23, 3 days longer than the time span between September 23 and March 21. Since from September 23 to March 21, the Earth is closer to the Sun than it is between March 21 and September 23. Therefore, it has a greater velocity. The third law links the period of revolution of the planet to its average distance from the Sun, such that the period increases along with the average distance. Convinced by Copernicus' theory, Galileo looked for the experimental proof. He made the first telescope designed for astronomical observations. He observed the mountains and the craters of the Moon, the Milky Way as a tight formation of stars, the phases of Venus predicted by Copernicus, and the 4 satellites of Jupiter. The year Galileo died was the same year Newton was born. He deduced the law of universal gravitation, which states that any 2 bodies attract each other with a force that varies with the inverse of the square of the distance between them and with the product of their masses. His discovery of the separation of white light by a prism incited him to construct the first refracting telescope that avoids the dispersion of colors by refraction. Discovering universe didn't stop in the 18th and 19th centuries. It continues its development. As an example, Edmund Halley detects the motion of the stars and put an end to the concept of sphere of fixed stars. William Herschel discovered the seventh planet in the solar system, Uranus. He also discovered the double stars. Urbain Le Verrier came up with the hypothesis of an unknown planet while trying to interpret the disturbances observed in the motion of Uranus. He discovered the eighth planet, Neptune, at the exact position predicted by the computations done according to the gravitational law. In the middle of the 19th century, the study and interpretation of the solar light spectrum led to the development of a new field of astronomy, astrophysics. Astrophysics is a science that studies the constitution, the physical properties, and the evolution of the stars. This is the end of the lesson. I hope you have enjoyed its nice information. Everything mentioned in the video is written in the summary sheet and to be studied. Have a nice day.